Hi guys, it's the Educator here. Welcome back to my channel. In this video, we're going to be looking at CHM111 revision questions. Alright, so if this is your first time turning to my channel and you have not subscribed, please do well to hit the subscription button, because trust me, if you don't subscribe, then you might not be seeing my videos again. And throughout these exams, I'm going to be dropping revision questions, possible questions that you can see, in fact real questions that you can see for your upcoming examination. Alright, so let's dive into the video. Meanwhile, a nomenclature video has been created, how to name organic compounds. So if you are still having issues naming organic compounds, please do well to check out that video. All right, so for the first question, we have which of the following best describes organic chemistry. So this is a very simple question. So you know that the CHM111 has to do with organic chemistry and inorganic chemistry, right? So correct answer to this question is B. The study of carbon containing compounds is organic chemistry. 2. Who successfully synthesized urea from an inorganic compound, helping to disprove the Vitalism theory? The answer to this question is Frederick Wöhler. Question 3. The ability of carbon to form 4 covalent bonds is, this is a very important question that you must take note of. You should know the characteristics of carbon, okay? Tetravalency, 4. The ability of carbon to form 4 covalent bonds is known as tetravalency. Catenation is the bonding, because carbon can bond, they can form long chain, very long chain. That is catenation. Please don't mix catenation for tetravalency. Number 4. Which hybridization is exhibited by the carbon in methyl, CH4? Please, I have explained hybridization in my channel in one of my videos. So please, if you happen to not know how to get hybridization, please do well to check that video out. Right, so the correct answer to this question is sp3. So now you might be wondering why it is sp3. There is a whole lot of explanation to why it is sp3, but there is a code. Once you know that code, you are good to go. So now once you see the number of bonds, determine what your answer is going to be. So now if you look at CH4, you ask yourself, one carbon in CH4, how many bonds does it has? It has 4 bonds. Of course, H, that's 4 bonds, which means that S is 1 letter, P 3 letters, that's making it 4 letters, and that gives us the 4 bond. So in case you might be wondering, say, what is this guy even saying? So let me see, we have C and we have H. So these are the 4 bonds, right? This is this methane, this is the 4 bond now. 4 bond, and now we have sp3. Now if they ask you sp3, how many letters? It's 4. Why? 4 bonds. That is just the trick to do it. If it is 3 bonds, you know that the letter that you should be looking out for is 3 letters, so you have sp2. It's simple. If it is 2 bonds, you know that letter you're looking out for is 2 letters, so you'll be having sp. Do you get that? So it's as simple as that. That's just the logic. Alright, question 5. The carbon atoms in ethane are dashed hybridized. So there are 2 formats that these questions can come out. Okay, the first one can come out as, they'll ask you the hybridization that a particular carbon atom exhibits. If they don't ask you that one, they'll ask you the carbon is what hybridization. So in the sense that you might see it as sp, sp2, sp3, just like the initial question, or you might see it as sp hybridized, sp. It's the same thing. Don't allow them to confuse you. So if you look at this question now, this question has, you have C2H4, right? C2H4. So now for C2H4, you have C. Now please take note. I know you might be tempted to say, how many bonds are here? How many bonds are here? Then you count and you'll be getting a very large number. That is not what I'm talking about. When you are doing hybridization, you consider one carbon. So now this carbon has how many bonds? Of course, it has 3 bonds, right? So you have 1 bond here, 1 bond here, 1 bond here. 3 bonds, which is going to give us sp2, 3 letters. So we have option D to be our answer. Number 6, the carbon atom in ethane, just like that. So ethane is going to be sp, just the way I explained. It's going to be sp. Okay. Number 7, Buckminsterfullerene has the molecular formula C60. So you guys did fullerenes, of course, in your lectures. Okay. So Buckminsterfullerene has the molecular formula C60. You should take note of that. Then next question, the molecular structure of Buckminsterfullerene contains 20 hexagons and 12 pentagons. This is something that you must take note of. Take note of this question, of this answer rather. Very important. Question 9. The carbon nanotubes are broadly classified into dash. We have option A, SWCNTs and MWCNTs. So you should know what SWCNTs means. You should know NT. Anywhere you see NTs in your exam is nanotubes, right? Nanotubes. So single wall carbon nanotubes and multi-wall carbon nanotubes, right? So now let's move on. Question 10. The nanoscale is generally associated with the dimension of approximately 1 to 100 nanometer. 1 to 100 nanometer. Alright, so let's move on. The inductive effect involves the displacement of option B is correct. So we have pi and we have gamma, right? So please take note of that. We have lambda as well. All right, then we have epsilon as well. Number 12, the effect involving the complete transfer of a pi electron pair under the influence of an attacking reagent is known as the electromeric effect. The localization of electrons in a conjugated system is known as resonance. These concepts are concepts that you must know. I beg in the name of God. All of these concepts are concepts you must know. It's a must. So if you are seeing this for the first time, please take note of them. Okay. So hyperconjugation primarily involves the localization of option A is correct. Number 15. Which of the following is an electron deficient species? We have carbon cation. You know, cation is plus, anion is minus. Plus in chemistry is actually loss, right? You know that, right? Why minus is what? Gain. You should know that by now. Gain. So electron deficiency, they are losing. So carbon cation. Then when you see carb anion, you know that it's what? Gaining, right? So a carbon cation is characterized by, of course, a positively charged. From the word cation, it is positively charged. Okay. Number 17. Which order correctly represent the stability of simple alkyl carbocations? We have option 2. We have the tertiary, then we have the secondary, then we have the primary, and then we have the methyl group. Okay. So moving on, we have the carb anion. These ones contain negative charge. I've said it earlier before. So this is option B. All right. Next question. A free radical is a species containing an unpaired electron. So when something contains unpaired electrons, it's known as free radicals. All right. Moving on, which type of bond fission produces radicals? The kind of bond fission that produces radical is known as the hemolytic fission. Which type of bond fission produces ions? It is the heterolytic fission. So please take note, homolytic, heterolytic, they have different products, and you must know the products that they give. 22. An electrophile is a species that accepts an electron. So there's a concept. We have the electrophile and we have the neutrophile, right? Electrophile, they accept. Neutrophile, they donate. Okay, so take note of that. So now, okay, we have come to the question. Nucleophile, not neutrophile. Nucleophile is a species that donates. It donates electron. Okay. 24. Which of the following is most likely to act as an electrophile? So basically, electrophile are most likely going to be positively charged because what? They are donating. Right? They are positively charged. So we have option C to be the answer. Okay? So they donate their electron and accept the pair. So please take note of that. 25. Which of the following is a nucleophile? So a nucleophile, this is a nucleophile. It's a nucleophile. 26. A reaction in which one atom or group is replaced by another is called substitution. When they replace one group with another, it is called substitution. 27. A reaction in which two or more species combine to form a single product without elimination of a small molecule is known as addition. When there is elimination, it is elimination reaction. But when there is no elimination, but you are adding, you are combining to form a product, it is known as addition. 28. Removal of atoms or groups from a molecule to form a multiple bond is characteristics of elimination. So you can see elimination, remover. Okay. Moving on. Which technique is most appropriate for separating liquids based on differences in boiling point? This is basic chemistry. Distillation, separation of liquid based on boiling points. Okay. 30. Fractional distillation is particularly useful for separating mixable liquids with close boiling point. So simple distillation is far boiling point. When it is close boiling point, you use fractional distillation. Okay. 31. Thin layer chromatography commonly uses which substances as the stationary phase? It uses the silica gel. All right. Now moving on, the RF value. RF value is a very important concept. The RF value in thin layer chromatography is given by the distance traveled first divided by the distance traveled by the solvent. So refractive front is more like the chromatography has to do with staining, ink, color, dye, separation of dye, right? And this thing travels, like it uses velocity, it uses speed. So we use the speed to separate it. So now how you get the RF value? In fact, they will not tell you to solve RF values. 33. The Lassen's test is commonly used for detecting nitrogen, sulfur, and halogen. Please, all of these things, all of these elements, and all of these compounds, they have tests. Please try to know the basic tests. 34. The process of determining the simplest whole number ratio of atoms in a given atom gives its empirical formula. So you should know that empirical formula is the simplest formula. Alright. 35. The molecular formula of a compound is always a multiple of the empirical formula. So that's why we see that sometimes you see something like this. This is, let's say CH2 is empirical formula. If you want to get the molecular formula, you just do N. It's always a multiple, right? It's always a multiple.